In this video, we will going to take up one more concept on projections of lines. That is on the introduction of projections of lines. That is the line inclined to VP and parallel to HP. How that will going to look in 3 dimensions. You can see here the line is inclined to VP. So this is the line capital A and capital B. The line is inclined to VP. How do I know that when the line is inclined to VP? Well, because since the line has to be inclined to VP, that image will be seen in HP. Since the image has to be seen in HP, then from where should I look? So I should look in a direction perpendicular to HP. So the direction in which I can look perpendicular to HP will going to be the top view. If I look from the top view, the 2 endpoints of the line A and B are not at equidistant from the vertical plane. A is at some distance and B is at some other distance. So therefore, the line will be inclined to VP. Where that image will going to fall? The image will going to fall on HP. You can see here, which is small a and small b. That represents the image in the top view. So the line is inclined to VP. And he says parallel to HP. As he says that it is parallel to HP means what? The 2 endpoints of the line are at equidistant from the horizontal plane. So since it is parallel to HP, where you should be able to see the image has to be seen in VP. Since the image has to be seen in VP, then if I want to see the image in the vertical plane, from where should I look? I should look in a direction perpendicular to the vertical plane. Which is the vertical plane? The vertical plane is here. Perpendicular to vertical plane means what? I should look from the front view. When I look from the front view, the 2 endpoints of the line, which is from here to capital A and also from here to capital B, both are at equidistant from the horizontal plane. Means what? Suppose if I say the distance from here to here is 50 mm, then from here to here also it is 50 mm. Therefore, the line is parallel to HP. So when you look from the front view, the image will going to fall on the vertical plane. So from A, so when you look from the front view, you can see that image from A is captured onto this vertical plane, then B is also captured on the vertical plane. Both A dash and B dash are at equidistant from the vertical plane. So the line is equidistant from the horizontal plane. So both A dash and B dash is above HP. That is why you can see here it is above HP. If the distance from here to here is 50 and also the distance from here to here it is 50, therefore from here to here also it is 50 mm. So when you join between these 2 points, you are going to get a line which is a horizontal line. Now, this is how I can say the line is inclined to VP and parallel to HP. So now the next concept is how to identify the true length. So the true length has to be, what is true length? True length is nothing but the actual length. If the line is of 100 mm, suppose if I say the distance between these two is 100 mm, in the view also you should get 100 mm only. You should get the 100 mm either in the front view or it should be in the top view. Suppose if it is the front view, it is A dash B dash. Suppose if it is the top view, then AB. Now, when you look from the front view, you can see the 2 endpoints are at equidistant from the horizontal plane. Now the line is parallel to HP. Since it is parallel to HP, then I can see the true length in horizontal plane. So when you look from the top view, you can see that it is having a AB. Whatever the distance from here to here is the same distance is from here to here. That means if this is 100 and this is also 100. So naturally, so this will going to be the true length in HP. So once it is the true length in HP, always the true length is identified or the true length is marked with capital A and capital B in bracket. So that is the reason why in capital A and capital B is shown in bracket in the top view. Since it is parallel to HP. Now since it is inclined to VP, as we see inclined to VP, that is with respect to this, vertical inclined to VP. So what happens in VP, you will get the apparent length. So since the image is on VP now, I have to look from the front view. So you will going to get A dash and B dash. What is the length of A dash B dash? The length of the A dash B dash is less than this length. So since that is the reason why this will going to be apparent length. So this is how we will be able to analyze the line inclined to VP and parallel to HP. See, this is in 3 dimensions which you have been able to understand easily. But how to represent that in your 2 dimension orthographic view? So what I am doing is I am rotating the horizontal plane by an angle of 90 degrees. Once you rotate by the angle of 90 degrees, then the corresponding images is also been getting rotated. So here the same thing has been copied. Now this is the front view and this is the top view. Now I want to find the true length in any one of the planes. If I want to find the true length in the front view, from where should I look? I should look in the top view. So what the top view says? Small a and small b, which is the top view. So what is the concept? If in the vertical plane, if the line has to be in true length, that is, if the front view line has to be in true length, the corresponding top view should be parallel to xy. That is the condition. If you see in the top view, the 2 endpoints of the line small a and small b are not at equidistant from the vertical plane, are not parallel to xy in the top view. Since it is not parallel to xy in the top view, therefore you will not be able to get the true length in the front view. So this length will going to be the apparent length. Similarly, if I want to find the true length in the top view, where should I look? I should look at the front view. What the front view says, A dash and B dash is parallel to xy line in the top view. Since the xy line, since the image A dash B dash, that is the front view, is parallel to xy in the front view, therefore its corresponding view, that is the top view, which is small a and small b, will be in true length. So that is the reason why we have marked small a as a capital A in bracket and capital B in bracket. The inclination made by the view with respect to VP is called phi. This is the actual notation which is used for true inclination with respect to VP. So how do I write in the orthographic view? You can see that in the orthographic view you can write like this. So we have an xy line with VP and HP. So I will consider in front of VP in HP, and I will draw a line of 100 mm, which is the true length, and the inclination is given. So I am going to draw this line. So then I will going to project to the front view, and I will take some distance and draw a horizontal line. I don't know what is the length of the line, it's not required. But only thing is, this has to cross the projectors of both A and B from the top view. So you will get A dash and B dash. Now, if I want to find the true length in the front view, I should look in the top view. The top view line is inclined, therefore this will not be in true length. Now the front view line is parallel to xy, corresponding top view, A, capital A and capital B will be in true length. The inclination made by this phi with respect to VP is called the true inclination with VP. So this is how you will be able to understand the line inclined to VP and parallel to HP. Next, we will go for line perpendicular to VP and parallel to HP. So if you consider like this, it is perpendicular to VP. Why? This line is exactly at the 90 degrees to vertical plane. That is from here to here, it is 90 degrees. And it is parallel to HP. So both the endpoints are equidistant from the horizontal plane. That is from this point to this, which is capital B, and from this point to this, which is capital A, are equidistant from the horizontal plane. Now the line is parallel to HP. If the line is parallel to HP, where you will be able to see the image will be seen in the front view. That is this point. Why you are getting a point? Because both B and A, when you projected in the front view on the vertical plane, both the points will going to be coinciding. And we have B dash and A dash. So why B dash and A dash? Because B dash, that is the image of the front view, and A dash is also the image of the front view. And both are coinciding, which is visible and which is invisible. When you look from the front view, B is nearer to the observer, so B dash is visible, and A is away from the observer, so A dash becomes invisible. So both the points of B and A are above HP by the same distance. Now, line perpendicular to VP. Perpendicular means what? It is 90 degrees to VP. So you can see this is the 90 degrees to VP. So when you look from the top view, where that image will going to fall? The image will going to fall on the horizontal plane. So when it is projected onto horizontal plane, you can see small a and small b. So when you are what you are looking from the top view, it is the point A is in front of VP. That image will going to fall on HP. That is why you have in front of VP here. So now this is the line perpendicular to VP and parallel to HP. So now since it is parallel to HP, so I can see the true length in HP. Where is HP? HP is here. So you can see capital A and capital B. So when the line is parallel to HP, you can see the true length in HP. So in other words, how do I know that the line is parallel to HP? From where should I look? I should look from the front view. When you look from the front view, that image will going to fall on the vertical plane. So if I want to decide whether the top view line is in true length, so I will look in the front view. So when you look from the front view, both the endpoints are at equidistant from the horizontal plane. So therefore, in the top view, the corresponding top view will be in true length. So you will get capital A in bracket and capital B in bracket in the top view. Can we get the true length in the front view? No, because I have to look in the top view. In the top view, if you look, both A and B are not at equidistant from the vertical plane. A is nearer to VP and B is away from VP by certain distance. So that is the reason why this view will not be in true length. And you are getting a point because the line is perpendicular to VP and parallel to HP. So that is the reason why you are getting a point in the front view. So this is how you will be able to analyze the line perpendicular to VP and parallel to HP in the 3 dimension. Now, how I can be able to represent it in the orthographic view? So when horizontal plane is rotated by 90 degrees, so HP will come down and VP will be above. So the above HP, which is B dash and A dash, which is parallel to HP, so you are getting the true length in HP. So you have capital B and capital A in brackets. And now, can we see this true length in the front view? No, because the top view line is not parallel to XY. But in the front view, that line is parallel to XY. Therefore, you are getting the true length in HP. So this is how you will be able to analyze it. And now when you want to give the exact orthographic view of this, just you copy this and remove these 2 lines. So you draw XY line, identify VP and HP, and you take some point from here, you draw a vertical line perpendicular to XY in the top view, and this is small a and small b. When you look from the front view, you are going to get a point, and this is B is near to the observer, so B dash is visible, and A is away from the observer, so A dash becomes invisible. So B dash and A dash in bracket. Both B dash and A dash are above HP by same distance. Therefore, in HP, you are getting the true length, which is capital A in bracket and capital B in bracket. And this is not in true length because both the endpoints are not equidistant from the vertical plane. So this is how you will be able to analyze the line inclined to VP and parallel to HP, and line perpendicular to VP and parallel to HP. Thank you.